I just built an n8n agent that with just one prompt generates new agents for you on demand. First scans a database with hundreds of automations, and then researches the latest documentation so that the AI can take the heavy lifting and assemble the workflow. And instead of you importing or copying over the code, it provides you a hyperlink that you can just click, import in your workspace, and start using right away. Now, it's not perfect, but it's a massive time saver. If that excites you, stick with me and I'll walk you through step by step. Let's jump in. All right, so what we have here is one main workflow, which is super minimalistic. And how it works is we pretty much have a chat, and when we send the chat what we want as a request to build the agent, it'll send that to our AI agent, and then it'll be smart enough to know that it should invoke this next workflow. And this next workflow looks a bit more complicated, but overall, we're doing a lot of the same things over and over again, and we're gonna walk through the general concept before we dive into all the little details. The end result of this whole thing is being able to go in your chat, and while you're having the conversation, you'll literally get a hyperlink in the chat that you can click to open up your brand new workflow, whether it's a normal workflow or an AI agent module workflow. So this is one example of a Slack to Google Sheet trigger, whereas we can go back and you can see, and if we go up in the chat, you'll see we also said, make an agent that goes through from a Google Sheet row and adds a LLM analyzing that row. So something super vague and ambiguous, but it was smart enough to know that because we said the word agent, that we're probably referring to the AI agent module. So if you click on this URL here, you should see the AI agent module with a draft of the workflow. And obviously you can see in the JSON step, it's not perfect, but look, this is already put together for you in literally a minute or two. So this is the power of being able to go from a very vague, minuscule prompt to something that really gets you started and get going. Now, how did we get all the bits and pieces to work together? I'm gonna walk you through that right now. And before we get into all the granular details, I'll just show you the big picture so you can follow along no matter how experienced or not experienced you are with n8n. We'll flick to some slides really quick and walk through the big picture at a very high level. So overall, we have a chat, and in this chat, all you have to do is be able to ask for the workflow you're looking for. So ideally, you want to name drop some tools, like I want to work with Jira or Zoom, and I want to attach that to Slack in some capacity, or if it's an AI agent module, you'd want to be intentional and say, I want to build an AI agent that has connectivity to tool 1, let's say Wikipedia, tool 2, Google Sheets, or tool 3, Google Calendar, and then we attach that to the AI agent. So the AI agent has a tool, and this tool pretty much just makes a call, a physical call, to the sub workflow to say, hey, we're the first line of defense, here's the request, here's what the person wants. And what we do is we use OpenAI to take that chat and make it slightly less vague, so it's easier to guess what the user is actually looking for. Once a sub workflow picks up that call, it then goes through a series of steps. One, talking to a knowledge base, which I'll get to in the next slide, and the rest is going through a bunch of perplexity steps. If you don't know what perplexity is, it's basically a tool that helps you search the internet on steroids. And what perplexity does in this case is scour the internet to look for n8n documentation to see how to assemble these different workflows using something called JSON, which stands for JavaScript Object Notation, which is basically the way that you see things on screen, all the different bubbles and nodes. Those are represented in a very syntactical and programmatic way. Once it has enough hints on how to actually build this JSON file, we then fall back to the large language model to put everything together so we can create that n8n workflow and import it directly in our workspace. But there's one more twist. What if we could go through tons of automations that are openly available on the n8n marketplace, especially for the AI category, and we could reference those like a book in a library and see examples of different workflows and their syntax to give us that extra cheat sheet on how to actually build this. And this is exactly the extra step we took to increase the likelihood that when we ask for a new workflow that especially it might not have seen before or is not that easy to research, that it has some form of cheat sheet database where it can look at a workflow, note the syntax, and have more confidence of how to construct it on its own. Now, this part of the process wasn't the most straightforward, so I'll leave this till later on in the video, and don't worry, I tried to templatize this experience as much as possible, so even if you're not technical, all you have to do is take a script, plug in some API keys, change some names, and you should be able to replicate this database on your end so that you can not only use it in n8n, by the way, but you can use it everywhere. Think custom GPTs or anywhere that can speak to an API. You can now have the knowledge of how to build n8n workflows or what they look like at your fingertips. With that said, let's go back to n8n and jump through node by node. So for this part of the workflow, things are pretty straightforward. You have your chat agent node here, and then you have your AI agent module, which is connected to OpenAI. In this case, I'm using 4.0 Mini. You could use reasoning models, but it won't make much of an impact, at least in this part of the workflow. And when it comes to the tools, all we're doing is dynamically invoking our next agent. And let's just double click on this. You'll see here that the query was, in my case, create a workflow that triggers when a message is received in Slack and then logs that message into a Google Sheet. And note here that we're using OpenAI to take that very vague example or prompt that I gave it and refine it so it's more well categorized. And then it says the Slack trigger should capture the channel, user, and message content, and the Google Sheet action should append this data to a designated sheet. So one important thing here is if you ever see this prompt not meeting your standards or it's adding too many components that you didn't ask for in your version of the prompt, that's where you can tweak this part of the process with that OpenAI chat module. So let's double click into this one, and then we'll see that on the left side, the query itself is a refined version of the original prompt we sent. So in this case, it took our gibberish and turned it into create a workflow that triggers when a message is received in Slack and then logs that message into Google Sheet. The Slack trigger should capture the channel, user, and message content, and the Google Sheet action should append this data to a designated sheet. So in this case, it's adding a few more steps than originally what I said. And if it's doing too much or being too proactive, you can just go back to that chat module and iterate it to your heart's content until it's saying exactly what you want to say. Other than that, we have the description of this tool, which is call this tool to create an AI agent after you have received the query variable, which is pretty much what we get here from the OpenAI after you've sent a chat trigger. And if we go down, you'll see in the workflow that we are selecting to invoke this other workflow called n8n agent creator subflow, and that's what leads us to the next part. So in this case, it's a bit more hands-on. So we'll zoom in a tad and go through one node at a time. So this first workflow input trigger receives the query we got from the first workflow, and then we prepare the search of that great library with tons of automation examples with a prompt here to make sure we standardize it in a way that it has the higher likelihood of finding search results. So if we double click on this OpenAI module and we just expand this prompt here, you'll see that it says, you are an intelligent vector store who has a large database of n8n workflows and AI agents stored in your vector database. Your job is to generate one short searching keywords prompts that allow to search the vector store with the most similar workflows to the query given below. The searching prompt can be a single keyword or a few words because the vector store will be finding the workflows based on the similarity ranking following the embeddings model attached to it. Also, the keyword AI and AI agent is mostly favored, so if there is a searching keyword with any of the two, then mix them as well. And here it says output in JSON format, and then here we give it the query that we received before. And the whole point of this, again, is to change that request into a more granular search request. Because like we said before, if we want to search this entire library of automations, what we did is basically tag every single type of automation with what it does verbally, as well as a very descriptive title with keywords. So imagine the title is agent underscore Slack underscore AI agent underscore Google Sheet. That would be the name of the automation that we wrote, and it has a higher likelihood of finding it if we focus on those keywords. And since an LLM will skew towards finding workflows that don't have the AI agent module because it's a relatively newer ad from the end of last year, we just say this whole AI and agent component specifically so that we have an extra layer of confidence of being able to find those workflows versus just a standard cookie cutter end-to-end workflow. And what we're going to do is use the output of this node to then look for the closest possible match in our library. So if we have our book titles or book search terms for this automation that's as close as possible to what was asked for, we're going to go through the library, look for the closest match, and once we find that match in this next node, we're going to pull all the thread of that match. So you can imagine a JSON file, which is what these automations are contained in, can be thousands of lines long. And the average embedding, which is basically converting words to numbers that an LLM can understand, or in this case, a JSON to numbers an LLM can understand, sometimes they're so big that you can't chunk them and embed them all at once. So you have to do it in piecemeal, depending on the size of the automation. In case there are different chunks or different parts of that automation that we don't have with that first match, we then pull and capture all of them together. So we have a holistic look of the entire automation end to end. So in the first node, we say we're looking for one main match. And then when we click out and go to the second one, and for this one, we have a limit of 5. And the reason why it's 5 is we looked at the automations that we stored in the vector database. And because they can't always be captured in one chunk, we noticed that typically the max of number of chunks that made up one automation were 5 separate chunks. So in this case, we're pulling on 5 threads of the same automation name, and then we're pulling that as a hint into our perplexity research step. So now in the perplexity step, we're going to have already a bit of a head start to inspire that research to say, hey, here's an example of a workflow that's kind of like what we asked for. Go and search for something similar, but try to actually satisfy the original request. So if we click out of here, then once we have this whole thread, we then combine all those pieces into one mega chunk. And then once we have this mega chunk, we then prepare our prompts. And what we did to make this as clean as possible is instead of having a perplexity step where we just inject the prompt outright, to make it cleaner and easier for you to update and for us to update, we have these JSON intermediary steps where our actual prompt is in here. So if we take a look at our model here, we have Sonar Pro, and you can choose whichever Sonar model you want. You can do normal Sonar, Sonar Pro Reasoning, or lately Sonar Deep Research, which takes around 6 to 8 minutes, so I don't recommend using it in a workflow yet. But if you need something very comprehensive or you want to experiment with it, give it a shot. We got to try it as soon as it came out, and it marginally made the results slightly better in some cases, but also slightly worse in other cases. And that's the catch with the reasoning models, is that sometimes they can overthink to the point where they go the wrong path, even though a more basic model can actually get it from the first time. So then in terms of the prompt, pretty much we say, your job is to take the following request and generate a structured step-by-step workflow that follows n8n's best practices. If you go down here, I go through a bunch of details on how it should construct this JSON, different things to look out for. And if you go down, you're going to see we have quite a few pointers for Perplexity on how to construct the JSON and things to look out for. But I'm not going to go through the entire prompt or the rest of the prompts, as you'll have access to this template and the underlying prompts in the description below, so you can look at them, read them, change them at your heart's content. So once this perplexity step is done and finished, we're going to use the output as an input to the next step to give it, again, additional hints so we can keep iterating and refining over this JSON to increase the likelihood that we have all the nodes we need and all the parts we need. Now this specific one here for add snippets, we added some special prompt here because of the tendency to forget or not know how to implement the AI agent module. Because the title of this video was how to have an agent build agents. It would be pretty poor if we couldn't build an agent module, which is the foundation of why everyone's so crazy about n8n to begin with. So in this prompt here, if we go down, we basically provide a JSON snippet of what the agent module looks like. Now we're doing this so that we can ground the search as much as possible, so it doesn't not just hallucinate, but also not start research down the wrong path. Now if we add reasoning here, it marginally improves the results, but for the cost-benefit analysis, Sonar Pro was good enough for all of these to get some semblances of workflows that we can actually use out of the box. If you want to swap out any of the examples we have here for any of yours, or give it different examples, completely up to you. We just found that this number of agent snippets were enough to give it enough of a clue to implement it properly more often than not. So in this case, one last thing to take care of is try, if you're editing this, to put this into a GPT or a Claude and have it implement the changes you want so that you don't have any syntax issues. Because when you use a JSON as an input in n8n as an example, you're going to find sometimes there's some parsing errors or syntax errors. So instead of you hitting your head against the wall doing that, try to get an LM to do that for you. Now, once we exit the add snippets, we hopefully have a refined JSON that if we didn't have the AI agent module before, now we do. And we feed that as input again. We create the JSON in the next step. In this case, for this prompt, we focus on the core portions of the syntax of the JSON. Here, you can read this all through. One of the major parts that I add here is property name issues. This is a major thing that will stop you being able to import workflows into n8n, is basically having parts of the JSON that are not correctly labeled or unlabeled at all. In this case, it says there are no reasons to get property name is property value errors, and you generate perfect syntax every time. And for the next one right here, comments removed, a lot of times OpenAI or Claude will inject comments into the code. And if there's comments in the JSON, it's just not going to work. It's not going to parse properly. So that's another instruction. And then we have some more tidbits here that you can read as well. And at the very bottom of the prompt, we're now referencing the query as well as the plan that we got from the prior steps. So if we click out of here, we have one more step to pretty much validate the JSON itself. And then once we validate using perplexity, again, we're now validating tier 1 against the documentation, and then we're getting OpenAI to validate the JSON in general. So we're using O3 Mini, and we have a prompt that goes along these lines that again goes through all those syntax issues I mentioned before and a couple more. And then if we pass this part of the step, we now go to my favorite module I didn't even know existed until very recently, which is this n8n create workflow module. So from a workflow, you can now create another workflow in your n8n space. So you don't need to download a JSON and import it. You don't need to copy JSON code from one area to the next. You can now generate this workflow for the edit fields manual part here. All we're doing is writing the name of the brand new workflow and storing it in our workspace to enable us to get that actual URL. So this URL here is what we're going to show as the URL in the chat we saw before. And if we go back and click on chat, you'll see that this view the workflow, this URL is being produced by this specific manual step. So this completes this sub scenario, and now hopefully you should be able to go to your overview of n8n and then see the brand new workflow it came up with. So now with understanding the core workflow automation out of the way, we'll focus on how did we actually put together this knowledge base that we refer to act as our initial cheat sheet. So this is the part I'm going to go through right now. Before we do that, I have one very important call out to make. Our early AI adopters community is finally launching on February 28th at 10 a.m. And this is your final chance, if you're a business leader, business owner, or CEO, to apply to the community and get the best price you'll ever get. If you like my free Mad Scientist experiments on YouTube, you're gonna love our business-focused content that'll take your company to the next level. If that sounds interesting, check the second link in the description below, and maybe I'll see you there. All right, back to the video. All right, so if I go to this group of tabs here I called Pinecone, I'm gonna first show you the number of workflows we have and what they look like, and then what they look like in the vector database in Pinecone. So if we go to this Google Drive here, my team and I scraped pretty much tons of automations from the AI portion of the free marketplace for n8n. And then you can see if we double click, this is what these automations look like behind the scenes. So you can visibly see webhook ID, parameters, you can see the actual names of certain nodes, like you can see here, Telegram, and this is what would populate that Telegram icon on the actual automation. So we took these, and those JSONs turn into these vectors, where we have an LLM in a Python script go through the entire JSON using O3 Mini because it has a very large context window, and it summarizes what that automation does. That's numero uno. Numero dos, we generate a title that again increases the likelihood that we find search terms that find a corresponding automation or set of automations. So in this case, we have a standard agent underscore airtable underscore chat underscore analysis. And as you go through, you'll see all kinds of different ones like Twilio underscore airtable underscore OpenAI. I'm trying to focus on the key tooling because the way you'll prompt it is typically by saying, hey, add an iCal module, add an airtable module, or add a Fireflies module. So in this case, you have that. And then we have the actual JSON file. And this one is a really good example snippet because you can see this one's probably so large enough that it doesn't cut off. And you can tell it doesn't cut off because when you see analyze data here, it doesn't have a closing bracket. Whereas if we go to a different one, you'll notice this one has the entire JSON automation in one shot because maybe it was small enough that it could actually capture it all. So in this case, this is why we had to do that chunking and round up all of our matches so we could put together and reconstruct any JSON file automation. So once we have this, we have around 398 individual vectors. And what makes it easy to quote unquote delete them is I've named them in a way that's very uniform. So if I say, hey, let's look for everything that's agent Airtable chat analysis, and I put that here and remove the one and search. So now that we have everything stored in our vector database, we can go and see how we actually got everything in there in a pretty dynamic way. So if we go into this Python script I wrote in Google Colab, now usually I'd write it in my IDE, but to make it easy to share and accessible, we have it in Google Colab, which is basically like a Google Doc, but for code. So you can share it and I can give it to you, you can import it on your end, and then just change what you need to change and then be able to replicate the same result. So to get started, all you're gonna need is a Pinecone API key, a region, which will come as soon as you create your index in Pinecone, and then an OpenAI key, and then the name of the index. So in this case, if we go to mine, the name of my index is n8n templates. Yours will be whatever you want. If you want to make things easy and be lazy, just name it what I named it. And in this case, I'm using an embedding model. This embedding model is pretty much what's going to convert the JSON files into numbers that an LLM can understand or reference. And if you want to see what that actually looks like, if you go into Pinecone and click on any of these records and click on Edit Record, you're going to see this values portion. This is the representation of that automation JSON within the vector space. So when you go and ask Pinecone, hey, find a match, this is the reference point it uses to actually find the closest match. So with that, all you have to do is enter those different components. If you want to use text embedding large, which is the larger, more expensive version of OpenAI, I recommend that for JSONs because it's a bit more complex. It's a bit larger of an actual file structure. So if you had the small one, you would probably need 10 to 15 different chunks for certain automations versus just 5. So depending on your budget and what you're looking to do, I recommend text embedding large, but completely up to you. If you switch it to small, you just want to make sure that you change the dimensions because the dimensions of the vectorization changes to 1536 with small versus large. So that's one more thing you'd have to change here. Everything else, including the prompt, you should be able to keep the same. So this is the public version of the code. I'm going to now run my private version that has my API keys and just show you what the process looks like when it's running. So this is my code and I'm going to run this second step that you have to run. All you have to do is click run once, and assuming that you have the right path for the folder that you have all of the automations in, you can click on connect to Google Drive. It'll ask you to authenticate and sign in, and this will essentially allow you to hook up your Google Drive to the session to look for the specific folder that you have with all the automations. Now, just to save you the scraping, I'm also going to make the n8n templates available for you via Google Drive, so you can just take that, import it, and what I recommend is just making sure you put it somewhere easy to access so that you can go and easily put in the file path that you need. Once you have that file path, all you want to switch is this folder path here, okay? And one easy way to get around having to worry about copying this URL is you go to Drive, and then you go to My Drive once you have it hooked up from the code, and then once you have that, you can go to n8n workflows, and for the URL, to save you the headache of having to figure out how to find the reference, what you can do is go to this folder section of Google Colab, and now that you have your Google Drive mounted or connected, you can click on refresh and you'll see this drive pop up. You can click on this drive, it'll reveal all the folders you have. So once you click My Drive and scroll down, you'll see that over here we have my n8n workflows, and when I reveal that, you'll see the list of every single one we have. All we have to do is right click on copy path, and then paste that path here. And now you're literally done. You have your API keys, you have your index for Pinecone, assuming you've created it. And if you go down here, you'll see it's basically saying generated a title. We have an LLM step from OpenAI that creates that title we talked about, the dynamic title. And you can see that right here, agent underscore chat underscore LLM underscore search report. And then we have the generated TLDR, the summary of the automation, which is right here. It says takes a user query, uses an AI to craft precise search queries, and then fetches and processes search results. And then, it keeps moving, but it says processed one chunk. So you can see how many different chunks did it have, depending on the size of the automation. Because we're using embedding large, we now have a higher likelihood of having only single chunk scenarios, which is better for us because the likelihood of having hallucinations or ramming way too much of a cheat sheet of the automation into the perplexity prompt is way lower. Now, because this part's a bit more hands-on, I'll include in the Loom how to create that pinecone index if you've never done that before, as well as how to set up and get some of these other key variables that you need to be able to go and get up and running with this part of the automation. And with that, you have everything you need now to start chatting and building n8n workflows on demand. So if we go in here ourselves and say something like, build an AI agent that will take information from a row in a Google sheet and then summarize them and email it to mark@promptadvisors.com and then send that over. This will start running. It'll invoke that next agent. And if we hang tight a little bit and go to the next part of the automation, we can go on executions. And then within seconds, you'll see it starts running. And I'll skip to the part where it's finished right now. And it'll usually take between 2 to 4 minutes if you're using Sonar Pro. If you use Deep Research, it could take up to 10 to 15 minutes.